Okay, today, guys, we're talking circles. As you can see, we have lesson number 9 today, and I have a couple formulas for you here to copy down. And I do want to remind you that a lot of the questions here on this lesson, I'm going to be referencing the formula sheet for. You do get this formula sheet with a bunch of geometry formulas on it for the whole test. And a lot of people just forget that it's there because you don't use it that often, but I just want to remind you that it's there. And these are some formulas that I copied down for circles. We've got area, circumference. Remember that the diameter is twice the radius. This is all stuff from a long time ago, even before geometry class that you first learned this. I do want to talk about the equation for a circle, though, because I'm not sure, depending on what math class you're in, that you have gotten to circles yet. This is the formula for a circle. And it looks kind of like the formula for a parabola in a weird way because we have the h and we have the k. That's very similar to the parabola. The difference is that x is squared for a circle and also y is squared. So anytime you see an x squared and y squared situation, by the way, it's being added together, that should clue you in that we are talking about a circle. And even if you haven't gotten to this lesson yet in math class, you could still be able to get some pretty basic questions right that have to do with circles. This might be an opportunity for me to teach you something new that you haven't learned yet in your math class. And the equation for a circle is always equal to the radius squared. So the number that's by itself on the this side of the equation for the circle is the radius squared. So you can square root this number to figure out what the radius is. Okay, notice that in the formula we have minus signs here, and it's just like the parabola. The h, the sign changes. The k, the sign also changes because it's inside the parentheses. So positive h, positive k is the answer here. So those signs will flip. I'll talk more about that when I get to an example. These are volume formulas that are also from the formula sheet that I'm going to reference when we get into some of these questions, okay? Starting off kind of simple and getting a little bit more difficult as we work our way through. Number 1, I'm going to give you a brief description here, but if you need more help on circles or anything circle or this lesson related, please come see us on a Friday, okay? We have a circumference of 31 pi. Anytime I see this word, I'm going to write the formula first, and then I plug in what I know. It says that the circumference is 31 pi. So for the circumference, I'm plugging in 31 pi, and I know that it equals pi d. And very simply, your pi's cancel on each side, and we have 31 equals d. It does ask for diameter, not radius, but if it did ask for radius, I would just cut this number in half, yes? And this is a non-multiple choice question. You just type into the box 31. Number 2, we have some stuff about arcs. I know you did this in geometry class. Maybe you forgot things about arcs. But this one's actually quite simple. I think you could probably use a little bit of common sense to process of eliminate answers here. But we have the circle above, and it tells us that we have a circumference of 36. Do you remember what circumference means? It's important that you understand that word. It means the distance all the way around, okay? Like the pizza crust, if you will, of the pizza. It's the circumference. And what is the length of the minor arc AC? It's called a minor arc because it's less than half the circle. FYI, a major arc is more than half the circle. And what is the length of it? Well, can you eyeball this, that we're talking about a quarter of the circle here? The reason I know that is because of this right angle right there. 90 degrees is a quarter of 360. Remember, in a circle, it's 360 degrees. So I know that this is just a quarter of the entire pizza crust. So I'm taking the 36, dividing it by 4, you get 9. Okay. Next one, still talking about arcs. We have, again, a circumference, which means all the way around is 144 pi. And these are both diameters. That's good to know because a diameter goes through the exact perfect center. And it's important also to know that that's the center, which means that this angle equals this angle. We've got vertical angles, and that makes this arc equal to this arc. Okay, we also have this angle equal to this angle, which makes this arc equal to this arc. Where did all these x's come from? Let me explain. It tells you that the length of PS, which is this, is twice the length of PQ. And since this is a diameter, that's half the circle. Okay, so that's why I put an x here and a 2x here. That's the relationship. And because of those, I can like reflect those over. This is x, this is also 2x because of our vertical angles here. Okay, so I've got this whole circle kind of labeled, and it asks what is the length of arc QR. So how long is this thing? Okay, Well, if we know the entire circumference, then we can multiply it by the fraction that this is, which happens to be 2 out of 6. But another way we could think about this is I first solved for x. I took my entire circumference, which is this, and they're telling me that, that I have all my x's here, so I added up x plus 2x plus x plus 2x, which gives me 6x. So I can solve for x. And just be careful because, look, that is one of the answer choices, but it's not the correct one. So just be really careful. A lot of people get too excited early in the question and they see something that resembles what their work has and they think that's the answer. But the question we have to answer really carefully. Read carefully QR. QR is right here. It's actually 2x, right? So we have to take whatever we got for x, which is this, plug it in, multiply it by 2. That's why the answer is 48x. Anyways, and it's also, if you think about it, this is like 2 out of 6 of the entire circle. That's the fraction that is. You could also take this number and multiply it by 2/6. Then you get 2 over 6. You get 48. Number 4. Okay, here's where we're using that formula for a circle that you have up at the top. Notice how I've got -8 here for the center, which means it's a double negative in the formula. Remember, in the formula, it's x minus something. So when you have x minus -8, it changes to a plus. Just be careful about the signs there. And you'll notice that that will eliminate 2 of the incorrect answers right away. Okay? Be very careful about those signs. It's y minus the y value, and the y value is 6. So that's why there's a negative there. And radius 5, remember that the radius, you square that number to get this. So I'm just matching up and choosing very carefully. The answer here is B. Oh, notice how these two answers are incorrect because that's the radius, and it's supposed to be radius squared right there. So process of elimination is going to help us, you guys. Okay, now we're getting a little bit harder. Once again, I can eliminate 2 incorrect answer choices knowing that this should be x plus 4 squared because it's a double negative. It would be x minus -4 in the formula. So it's x plus 4, eliminate this, eliminate this. I'm down to a 50-50 shot. And the point -8 lies on the circle. So let me see if I can get a quick sketch. Where's -4, 5? This is the center of the circle. And it says that -8, 8, 5, 6, 7, 8, 6, 7, 8. This is on the circle. So it looks like the circle looks something like that, okay? And we have to figure out what the radius is. It's not easy to count from the center to the circle, but you could maybe make a guess and tell that the radius is maybe something close to 5, but remember that you have to square it. So it can't be either of those answers. How do you actually come up with the question? Do you remember distance formula? That is what I'm trying to figure out, is the distance between the center and this point. This would be the radius. And if I have both of those ordered pairs, you can do the distance formula to calculate it exactly. And remember that you take your x values and you subtract them, and then you square the number. Plus, you take the y values and you subtract them and then square the number, which gives us root 25, which is 5 for the radius. That means that 5 goes right here, but remember you square the radius in the equation. So 5 squared is why the answer is D. Number 6, we have a cylinder. I am going to reference the formula sheet. I also forgot to show you that circles, those equations that I wrote at the very beginning of the top of the page, here's your equations for circles. But this next question is asking about cylinders. Where's that? Here it is. There's the formula. Don't forget that it's there. And we're going to use it, and I just copied it. I know I'm talking volume of a cylinder, so I start by just copying the exact formula, okay? And it tells me that the volume is 45 pi, so for volume, I'm plugging in 45 pi, and I'm keeping pi r squared, and it also tells me the height is 5, so instead of h, I'm putting 5, so plug in all the numbers you know. Looks like I divided both sides by 5 first to cancel the 5 here, and that changed the 45 into a 9. And you can also notice that the pi's on each side cancel, so that's why we get radius equals 3. Don't forget, my friends and family, that you have the formulas on the formula sheet. Sometimes people don't even look at them. You forget that they're there. Okay, number 7. We again have a cylinder, and we're talking volume, so notice I just wrote the formula right away. The formula from the formula sheet that you do not have to have memorized, which is a beautiful thing. And it has the diameter of 8, and I know that there's an r in my formula, so be careful about that. That's one of the ways that SAT will try to see if you're like reading carefully, right? This is the diameter, we need to know the radius. So the radius is what goes into the formula. And the height is 12, and so that's actually very simple. Just follow your order of operations. We're going to take 4 squared, which is 16, and then times it by 12, which gives you 192 pi. Beautiful. Number 8, here, now we're getting into some level 3, some difficult questions. But the length of one side of a square that has the same area of a circle with radius 2. This is a bit confusing. I drew a square, and what I know about squares is that all the sides are the same, so I put x and x. That's what we're trying to figure out. Okay, and now I have this circle also, so I drew a circle. It has a radius 2. I know the formula for area of a circle, which tells me it's 4 pi. And it says that the area of the circle has the same area as the square. So I labeled the 4 pi right here inside the square. And I know stuff about squares such that x times x equals the area. Remember length times width? That's how you do the area of a square. So x times x is x squared. I equaled it to 4 pi. And in order to get x by itself, you square root both sides. So I square rooted this and I square rooted this. You just have to be careful when you square root 4 pi. Okay, the 4 square roots, but the pi does not. So essentially you can break down the 4 and pull out a 2 because the square root of 4 is whole number 2. But the pi, you cannot really square root. It's not a squared number. So I left that in the radical. And check out these answers. They all look very similar. So choose carefully. Be very careful about that one. Number 9. We have a cube with a sphere on the inside of it. I drew a cube as best as I could, and I drew a basketball on the inside of the box, if you will. That's what this question is talking about. And we have all this empty space on the outside that we're trying to calculate, okay? And it does tell us that the cube, which I know length, width, and height are all the same. So I labeled them all 68. That was given in the question. And it says the solid sphere with a radius of 34 is inside of it. So 34 from the center to the outside is the sphere. Okay, to the nearest cubic inch, what is the volume of the cube not taken up by the sphere? So we're going to subtract the volume of the cube, and we're going to subtract away the sphere, and we're going to be left over with this outside area. And just remember, I'm going to go back to the formula sheet. We have the volume for a cube right here. Okay, it's 4/3 pi r cubed. Be careful with the cubed because a lot of people think that it is squared or they look at it too closely. This is a cube right here in the formula. So for a cube, we have length times width times height. So I plugged in all the 68s. I got this number. Great. Simple with a calculator. No big deal. For the sphere, I'm using the formula from the formula sheet, and the radius is 34. So I plugged in 34. You can type this entire thing, including the pi button in your calculator, or you can use 3.14 for pi. But I know that my answers don't have pi in them, and it's asking me to round to the nearest cubic inch. That means that you have to use 3.14 for pi. You can check this, type this in the calculator, and make sure you get this answer. Make sure you know where the pi button is. Let one of us know if you need help finding it. But I am subtracting this number minus this number, and I got that, which is very, very close to this. It did tell me to round, so that means I know my answer will not be exactly what my choices are, but I'm going to pick the closest one to it. Okay, and then last question, you guys, number 10. Save the best for last, maybe. We have the length of an arc right here. I have it kind of colored. ADC. How do you find arc ADC? You trace it with your finger. Start on A, go through D, and then to C. That's the arc that we're talking about. And it's 5 pi, so I labeled it 5 pi. Remember, the digital SAT is digital, so be very careful and make sure that you actually draw pictures like this. You might have to copy diagrams onto your paper to help you think your way through and label stuff, okay? X is 100 degrees. That goes right here, the 100 degrees. I have an arrow pointing to that X. And what is the length of ABC? Excellent. Trace it with your finger, A to B to C. I can figure out that ABC is 260 degrees because there's 100 degrees here, and I know that they all, like all the degrees in a circle is always 360. So I subtracted 100, figured out what I was left over with. That's 260. And I think I'm just going to set up a proportion. I know that this degree cuts off an arc of 5 pi. I also know this degree, and it cuts off an arc of x. Okay, so I did 5 pi over 100. That's this arc over this. And I don't know what the other arc length is, 5 pi, but I do know that the degree is 260 degrees. So you just cross multiply, get 100x, and when we cross this way, we get 1300 pi. And yeah, you can cancel the zeros on each side, and we just get x equals 13 pi. There you go. If I went too fast, come see me on a Friday, you guys. I'd love to explain this a little bit slower for you, but that's your crash course on circles. Thanks for watching.